All right, today we're looking at 11.5, division of polynomials. Today we're going to divide a polynomial by a monomial, and we're going to divide a polynomial by a binomial. Okay. So looking at this, we're just looking at dividing and kind of splitting it out. We have to remember the rules of division of fractions. So we start out with the first one. We have two, stupid marker. There we go. 2x squared plus 16x divided by 2x. Okay, so we're looking at this one. Well, you know what can we cancel? What can't we cancel? A couple different ways that we can look at this to simplify it. What we're going to do is we're going to kind of do like reverse adding of fractions. And so whenever we go reverse adding of fractions, I'm going to say 2x squared divided by 2x plus 16x over 2x. So all I did is I split the fraction. So, we know we have common denominators, we can add the numerators. That's really what we're looking at here, but we're splitting it. So we already have the numerator combined. Now we're splitting it apart. We have this common denominator. We split that thing apart, and we're looking to simplify it this way. This is one way you can look at to simplify. I don't really like this way. I'll show you a different way here in a little bit. So we look at it and say, okay, that's the way we're going to simplify this. Looking at this, now I can simplify this thing right here. I have 2x, I have 2x squared, so I'm just going to be left with an x in the numerator. So it's really x over 1. We know we can multiply, divide, anything like that by 1. Plus, then we divide this. We have 16 divided by 2 is going to be 8, and the x's are going to be canceled. So it's x plus 8 is the way that we see that. Another way we can look at this, and this is the way that I would recommend, this is the way I think I like working them a little bit better. We can't simplify quite down as far as they might be able to here, but I look at it and say I can factor out and say, what's in common with both these? Oh, 2x. Huh. That just happens to be my denominator. Then I have this group of x plus 8, 2x. And then we know that this group here, I can't just pick and choose because it's a group. That's the same thing here. I can't just pick and choose and go, oh, there's a 2, there's a 2, oh, there's an x, and I'm left with x squared plus 16. It doesn't work like that. That's picking and choosing. We cannot do that. No, no, no. Okay, so we look at this, say, whoop, whoop, equals x plus 8, which we end up with the same thing. So we end up with the same thing. We simplify it that way or that way. And the nice thing is because we had it cancel out with the denominator. So we can do that with the numerator if this was flipped over. Okay, if we had 2x over 2x squared plus 16x, we cannot cancel this. We cannot split this. That's not the way fractions work. Okay, fractions work with the denominator. Denominator being one thing. Okay, just remember the rules of fractions, and this is pretty easy. If you forget the rules of fractions, go back. We worked them right before break, or I call this a break, but not really a break. Right before the outbreak. There we go. B squared plus 12b minus 14 over 3b. Okay. So what we're doing is we're going to try and simplify this. This one here, really factoring out, it's not going to work. It's not going to give us nice things. You know, two numbers multiplied together this tells me the signs are opposite. It tells me the bigger one's positive. So 14, 1, I don't even know if any of them is going to factor out. So it really doesn't work. So we're going to go with their method, b squared over 3b plus 12b over 3b minus 14 over 3b. Okay, still on the screen. Okay, so we have this. We look at the cancellation here. B squared, there's a b. So I'm left b over 3 for this first term here. Then I go this one, and I have 12 and 3 is going to give me plus 4. The b's are going to cancel, so there's nothing else. Minus, don't lose those minus signs. 14, 3b, nothing really cancels there, so 14 over 3b. Looking at this here, we might be used to starting out with something like this, and we say, oh, hey, find the common denominator and add it up, and then we end up here. And so what they're doing is just showing you, hey, we started here, we end here. Most of the time that we've done the math, we start here and we want to end there. So they're showing that reverse math. So we want to make sure that you understand what's going on there. All right. Example number 2, divide a polynomial by a binomial. So a polynomial and a binomial. Monomial is only one thing, so a binomial is 2. And a polynomial is multiple. So we have h squared plus 9h plus 18. There's our polynomial. Okay, it's actually a quadratic. An h plus 6. Right? Looking at this one here, now all of a sudden they go that other direction. Okay, so we're given a lot of different tools, and it's just when do we use these tools at different times? If I want h squared divided by this, 9h divided by that, 18 divided by that, nothing's going to cancel. So it really doesn't do us any good that way. So we have to look at it and say, well, what's another way that we know we can split this apart? This is a quadratic, so I can look at it and say, well, 2 numbers multiplied. This tells me the signs are both positive, or both the same. This tells me they're both positive. So 2 numbers multiplied together to give me 18. They add together to give me 9. 2 sets parentheses. H plus. Looking at 9 and 2. That doesn't quite work. That's 11. 3 and 6. 3 plus 6 is 9, and that would be 18. So 3, 6 over h plus 6. And since we are doing math problems, we should have kind of hinted at that. You know, kind of those little reviews that you can say for like an ACT. You can look at it and say, hey, what should cancel out? So you can kind of have a little bit of heads up what it should be. And we see that now this is a group down here. Remember that h plus 6, that's an entire group. So this are canceled, so we're left with h plus 3. So that's it. And if you write it sloppy enough, it could look like an N, give it a little higher hat. So we have h plus 3. That's what we're going to be left with. And I can cancel that because it's whole group. Anytime I say x equals h plus 6, so if I substitute that in, I have x over x. Oh, hey, x's will cancel. So if x's can cancel like that, the h plus 6 can cancel like that. Just a little trick to be able to kind of look at it and think about a different way to solve it. Next thing they're going to do, they want us to do long division. Oh, no. I have to remember how to do long division. What? Long division of polynomials? That's a foreign concept. Okay, so we have y plus 3. Got our little doghouse. Y squared plus 4y plus 12. Okay, so this is division that they're looking to do. We want to look at this and say, okay, now, y plus 3. What do we need to multiply y plus 3 to get into this thing? Well, need to multiply by y, so I'm going to put a y up here. Y times y is going to be y squared. Y times 3 is going to be 3y plus 3y. And remember that we subtract. So anytime we multiply this, we subtract the second line. Got to remember we're doing that in division. We have to make sure that we have that all the way through. Don't just subtract the first term. Subtract every term of that binomial. So subtract down. Whoop, got a 0. Oh, just got a y plus 12. Okay, y plus 12. They say, well, what can we do here? It can still go in one more time. I can't multiply this by 2. That's not going to work. It can go in one more time. So I go plus 1. So I say y plus 3. Got to remember, we're going to subtract these. Okay, so I'm subtracting them down. So 12 minus 3, I think it's like a 9, maybe, give or take. This is going to be a 0 here. Okay, so a 0 plus 9. So I have a remainder of 9. Good. So if I look at this, I say, well, what I have so the answer can be written as y plus 1 plus 9 divided by y plus 3. Okay. So this one, you know, this came out. That's nice. This came out. That's nice. This one here, oh, that was a little bit different. And so this is another way to work out. This is just using the long division. So I have the binomial divided by binomial. There's a remainder here. So, you know, 2 numbers multiply together to give you 12, and they add together to give you 4. Don't think it's going to happen. Okay. So, because 3 and 1, no. 4 and 1, you know, nothing even multiplies up to 12. I'm just trying to think of how to get it to 4. No, it's not going to work. So that's why I have to do it this way. So we have y, so y, it's already divided out, plus 1, and then that. It's kind of a little tricky. So the little trick to it is we have this, and then we have this remainder, and this remainder still needs to be divided by that. That's why we write it like that. So the y plus 1 is that first term, plus 9 still needs to be divided by the y plus 3. So that's kind of that little trick to that one. Okay, long division can be a little bit tricky. All right, real world example number 4. The expression 5x plus 250 represents the cost of rental or renting a picnic shelter and food for X people. The total cost is divided evenly among all the people except for the 2 who bought decorations. Find 5x plus 250 divided by x minus 2. Determine how much each person will pay. Right? So we're going to use long division on that. So we have the x minus 2. It's always a question, where am I ever going to use long division? Oh, I'm never going to use it. Well, actually here you're going to. 5x plus 250. Okay, so I look at, I'm trying to get rid of that first term, so I need to say, what do I need to multiply x by to get 5x? That's a 5. Pretty Joe obvious. 5x minus 5. Change the signs. 0 there, and I'm going to get 255. Remember, change the sign. So we get 255. So then we look at our answers here. The answer is going to be 5, just like the last one. We have 5 plus 255 divided by x minus 1. So this is how we can figure out how much everyone's going to have to pay. So it depends on, how many people show up. If we have 256 people show up, it's going to be $6. Okay? Because we got to go 256 minus 1. So we 255. 255 divided by 255 is going to be 1. So 5 plus 1 is going to be $6 a person. So this is just the way they figure it up. And so it doesn't matter however many people show up, we can easily calculate it. It just happens if some people are leaving and some people are still coming in, that's when you're going to have a little bit of a problem. Just got to send everyone a bill, I guess. All right. Have any questions, comments, or maybe I should look at the last term? Example number 5. Before I go on, and questions, comments, thoughts, concerns. Okay. Example number 5. Look at that one there. C minus 1 division C cubed plus 5C minus 6. Okay. So look at this and say, well, what do I need to multiply by? Oh, we're missing a term in there. Okay, I got to be a little bit careful with that. This is where I'll use like a little bit of different writing. Maybe. Hopefully this marker will work. Sucks. That is a Sharpie in a dry erase. Oh, that one won't. Okay, so we're missing that c squared term. So it's 0 c squareds. So we know that we have that in there. We just got to keep that in the back of mind. We could rewrite this and say that I have the c minus 1 divided by c cubed plus 0 c squared plus 5c minus 6. Or we can say, you know what? I know what. I'm going to just use it in my head. I need to multiply c by c squared. So I have c cubed. The c squared times c is going to be c cubed minus c squared. Change those signs. I look and say, oh, there's nothing there. So I'm just going to add down. I get a 0 there. I'm going to get c squared. If I want to bring the rest of the stuff down, that's fine. Okay. I just kind of do long division a little bit different. So look at this and say, let's go plus 5c minus 6. So if I want to bring it down, that's fine. There's no problem with that. I need to multiply this by c, so plus c. So I have c squared minus c. Change my signs. And then add myself down. So 0, 6c minus 6. I need to multiply this by 6. So plus 6. So 6c minus 6. Change my signs. And it equals 0. Ooh, it goes in perfect. So there's our answer right there. C squared plus c plus 6
and we really cannot factor it down any further, and so we are done. So sometimes they will come out perfect. There's no remainder on that. If there's a remainder, we'd write whatever the remainder was, because 0 divided by c minus 1 is 0, so we don't have to do that. Okay, if you have any questions, thoughts, concerns, let me know. You know my email.